Hello class 9. Today we are going to discuss the equation of motion again, that is already we have discussed with the graphical method, but today we are going to discuss it in a different way. So let us start with it. Okay, so we are going to discuss the equation of uniformly accelerated motion. So let us start the very first equation. Now we will consider a object which is moving with initial velocity u such that its acceleration is uniform acceleration is a. After time t, the final velocity of the object becomes v. Now the acceleration in this case will be, see, we know that the acceleration is given by the formula acceleration equals to change in velocity upon time period. So we write it as a equals to change in velocity, that is v minus u over t. Now if we cross multiply t to a, that is at equals to v minus u. This is going to become as v minus u equals to at. So this is the very first equation of motion. Now children, if it comes in the examination, so you will be writing it as first equation of motion, then you will be mentioning out that a body is moving with initial velocity u such that after time t it's moving with acceleration a and the final velocity becomes v. Then the acceleration will be a equals to this, and you'll be then mentioning the formula and driving the first equation of motion, that is v minus u equals to at. Now coming to the second equation of motion. Second equation of motion. Now let us see for this. See, again the same thing you are going to write. Consider a object moving with initial velocity u such that the acceleration is uniform for it. Then after time t, the final velocity becomes v. Then the average velocity for that particular object will be, average velocity for that particular object will be equal to, what was the formula for average velocity? It was given as u plus v over 2. Okay, initial velocity plus final velocity divided by 2. So the distance traveled will be equal to what? See, distance is equals to velocity into time period. So this velocity will be written over here, average velocity into the time. Average velocity will be written as u into v divided by 2 into time. Now let us again see for the second equation of motion. We have s equals to ut plus half at square. We does not have v in the formula. So we will be removing v from here. Then from first equation of motion, we can substitute the value of v over here. This is, see, u plus v equals to u plus at. So we will, in place of v, we will be writing u plus a t divided by 2 into t. You can also write over here. Okay, you will be mentioning over here from where the value of v has come, that is from the first equation of motion, from first equation of motion. Okay, now let us see 2u plus at divided by 2 into t. You multiply t with this, you will get 2ut divided by 2 plus half at square. Cancel out 2 with this. This will be s. So value of s equals to ut plus half at square, and this is our second equation of motion. Now coming to the third equation of motion, let us see third equation of motion. Again the same thing for the third equation of motion. You will be writing, let a body be moving with initial velocity u Then after moving with initial velocity u with a uniform acceleration a such that it covers a distance s, and the final velocity is v. Now we will be, for the third equation of motion, we'll take the second equation of motion. From the second equation of motion, see, we are going to derive the third equation from the second equation itself. So from second equation of motion we have s equals to ut plus half at square. Now the third equation of motion is v square equals to u square plus 2as. There is no t in this. So what we are going to do, we are going to substitute the value of t from first equation of motion in this. So from the first equation of motion, you can write from the first equation of motion, t equals to v minus u over a. We have a equals to v minus u over t. Now we can write it in the other way also, t equals to v minus u over a, and substitute the value in the second equation of motion. So substituting the value in the second equation of motion, we have, let us see, we have s equals to ut plus half at square, and value of t is v minus u over a. So v minus u over a plus half a v minus u over a square of this. We will be writing v u minus u square over a plus half, or you write a by 2 v square plus u square minus 2 uv according to the formula upon a square. Okay, now let us see ahead. A plus, if I open up the formula, a by 2a square v square plus u square minus 2uv, a will cancel out one a from there. Okay, so we have vu minus, now we will be taking the formula. See, I am doing it in many steps so that you people can understand. But if you want to reduce one or two steps from here, you can directly jump up to this step, okay, or you can omit this step. So now taking the LCM, it is 2a, multiply 2 over here, so this is 2 vu minus 2u square plus v square plus u square minus 2uv. So these two terms are going to cancel out. We will be left with v square minus u square. See, minus 2u square plus u square will become minus u square upon 2a. Cross multiply this, you will get 2as equals to v square minus u square upon 2. Don't write this. This will become v square minus u square equals to 2as. So this is our third equation of motion. Okay. Now children, I hope you must have understood all the three equations of motion. You can go through this again and please note it down in your copies, the derivations. Before starting with the derivation, please specify the initials which are used, what is a, what is u, what is v, what is t in this accordingly. So now in the next segment we are going to discuss with our numericals for all the three equations of motion.